Hello and welcome back to my Astro Imaging Journey channel. My last video I showed you the flashlight I was using, but now I want to try to do something a little bit different with my rig, and I already took some pictures earlier that I'll start putting up here. The first thing is the other day wasn't exactly nighttime, but it was during the day, and I was sitting there in the inside, and the power flickered, and I got to thinking, there's no rain, no clouds, wasn't really that hot, and we're not prone to brownouts around here. Why is the power flickering? Well, what if that flicker happens in the middle of the night and the imaging session's going on? Am I going to lose half the night because the power did kind of like a brownout situation where it just dims down enough that the equipment resets itself? Happens to the cable box, happens to the TV, can happen to the equipment, right? Well, I'm here, I'm at home, I've been running AC pretty much the whole time. Really haven't ran off the battery. Everything's been 120 volt, and with the exception of the dew heaters, I believe, which are powered by 12 volt. I have a 110 to 12 volt adapter that I run that off of. So it's a 110, 120 supply coming from the house out there via the extension cord, and made it through this past year without a problem. But it also got me thinking, a couple videos ago, was doing the Mercury transit practice, right? Not going to be able, like I said in that video, I'm not going to be able to do that imaging from here. I'm going to have to go to a remote site. Can't guarantee that I'm going to be at a place where there's going to be electrical power, and I'm not going to drag my generator with me. So what is someone to do? Well, I'm probably going to set it up close to my vehicle, and I could always put an inverter in my vehicle, run the cord over to the equipment. I do have some vibration pads to put underneath my tripod legs, but so if I do have to start the vehicle, it should not impact the imaging. And we're talking about solar, we're not talking about 5-minute exposures, so vibration shouldn't be too much of an issue. But do I really want to do that? Well, I tested it, and the laptop I use is right at 150 watt requirement, and then all the equipment on top of that, and the only inverter I had is 150 watt inverter. So I plugged my laptop into it, and it faulted out because it was drawing too much on startup. It was 150 sustained with, I believe, 175 peak draw. So I needed a beefier inverter to go off of, and I happen to have a spare deep cycle battery as well. So what I've done is I've gotten a 3-amp charger and charger maintainer, and what you should see on the screen now is that connected up to the battery. And then from the battery I ended up getting it says it's a 2000 watt, but that's 2000 watt peak, 2000 watt startup with 1000 watt sustained draw, and that should allow me to run my gear, my laptop, anything I should need out there. And it's a deep cycle battery, so what I've done tonight is it's out there, it's hooked up, everything is plugged into the inverter, so hopefully it'll run off the inverter, which is drawing its power from the battery, and then the maintainer will keep the charge into that battery overnight. And with any luck, tonight's imaging session, the clouds have moved out, so hopefully we get a full night's imaging session essentially using the battery. But like I said, the maintainer's on there just because I don't know how long that battery will last with the draw from the equipment. I will have to test everything out using that later on. But for now, I just wanted to see if using the inverter off the battery will power the equipment through the night, even though I do have the maintainer, the charger on there to keep the battery level up. So yeah, hopefully this works. I'll let you know after the imaging session if I got a full night and we didn't lose power. So let me go take an image of this thing turned on for you so you can see. And what you should see here is the inverter. As you can see on the display, it on the right hand side of the display, it has 12 volts plus or minus a little bit. That's the charge coming from the battery. Also has a little charge indicator, little funnel looking thing with different LEDs in it to indicate how much of a charge is coming, how much capacity is left inside that battery. 4 bars is a full charge, and 75%, 50%, 25%, so on and so forth. To the left hand side, you'll see that it says roughly 118 to 120 volt output on the inverter side, and what you're not seeing is any indications of a load. And it does have a load indicator, much like the charge indicator on the right hand or the left hand side for the battery, so that you know how much of a load you're pulling through the inverter. So since there is no load indication, we can assume that it's below 10% or whatever of the 1,000 watt output. So that's good news. That means we probably should be able to run this thing all night long, even if I didn't have the maintainer on there. This will also help with any surges. One of the concerns I've always had, even though I have a surge protector multi-outlet outdoor grade, meaning it can't go in the weather or rain, but it can be outside and there's moisture in the air. So it is outdoor grade, and it does have surge protection on it, but those of us that have actually been through lightning strikes and different things, you get a surge on the line, that protector will probably protect you 99.99999% of the time, but all it takes is that one time out of 1,000 to hit you or whatever it is, and pop through that just enough to fry some equipment. I don't want to lose my camera. I want to lose my mount. I want to lose anything that's out there and have to replace it. So I'm hoping that using the battery with the inverter will also help prevent any of those surge damage issues as well. So let's see how this runs tonight, and I'll give you an update after the evening is complete. Alright, sorry for the narration, but the audio was just way blown out. As you can see here, it's running, and I've started the auto alignment with the star sense, and where you can see on my finger pointing here, on the right hand side is the load indicator, and even with the motors running, there's no indication that there's any load. They kind of look like they're lit up, but if you look to the left hand side with the charge indicator, they're nice and bright, so there's hardly any load on this inverter whatsoever. I definitely went larger than I needed to, but that's okay. Better to have too much than not enough. Sorry for the video quality. Shooting at night kind of sucks actually, but gives you a good indication. So I'll be back after the session's done, and we'll
we'll see how things progressed. All right, what I want to show you here was the display of the 3 amp uh, charger maintainer. And as you can see, it says 72%. That was when right after I shot the video showing the inverter display. And, uh, about an hour and a half, 2 hours later, I went back out and checked the display. And, the display does auto shut off, and you can just hit a little button to turn it back on. And it was reading 96%. So, with all the gear running without the laptop connected, it was definitely putting more charge into the battery than what the inverter was drawing. The inverter and the gear was drawing, which is a good thing. So uh, I feel confident that with this setup, I'll be able to have enough juice through the night. My worry was that there'd be more draw than there would be charge applied, and it would slowly drain. Uh, but that clearly isn't the case. So we'll be back after the session, after the imaging session's done, and I'll let you know how everything fared out. All right, and the imaging session has been completed for the night. And rather than set up my camera and get in front of it again, here's the image of the inverter again. So it worked flawlessly. Worked through the night, no hiccups. I know a lot of people run strictly off a battery and 12 volt and all that, so I didn't have any fear that I'd be able to run through the night and uh, have any issues. I just knew, or I just had a little bit of anxiety over whether this particular way of setting it up and converting the 12 volt to 120 volt uh, would do me well. I didn't want to go out and buy a bunch of 12 volt power supplies and connections to run my gear for, you know, that 1 or 2 times a year where I might need it. Uh, so, the inverter I can use for other things, and it's multi-purpose, so that works out better for me. And all's good and well. Last thing I wanted to point out here is if you notice on the battery, it actually has 4 terminals, 2 negative and 2 positive. The charger is connected to the smaller posts, and then the inverter is connected up to the larger posts. That's just the way I set it up. It doesn't matter which way they're connected. But the one thing to keep in mind is that I wanted to keep these things separate. I could hardwire these and put ring connectors on and use the screw posts and put nuts on them and washers and connect everything up to the screw posts, so it'll be a little bit more permanent. But this way, they're more temporary. I can move them around if I need to. They're pretty well clamped on there. They're not, unless that deer or bear go traipsing by there and trip over the cables. Really don't have any fear of those popping off. But the biggest concern there is when the charger is putting the charge onto the battery. I didn't want the charge from the battery to inadvertently over, push more than what it needed to the inverter. Now the inverter has a built-in breaker and should be able to take 20 amps, and this is only pushing 3 amps. But electronics being electronics, you never know what's going to happen. So having them connected to the different posts hopefully should allow the battery to be a little bit of a buffer and not throw the charge directly from the charger to the inverter, and therefore creating some type of an overload situation with the inverter. Uh, time will tell, and hopefully I never have to have any type of a surge or anything that would test that theory. But take the precautions when I can in the beginning, so that we don't have to learn by some unforeseen mistake. So with that, I want to say the imaging session went well. I got a lot of images on some clusters. The moon was about 85% tonight, so I could only do 1-minute subs on clusters. I couldn't do any nebula or anything since I am using a DSLR. And the moon would just wash out the images way too much. So other than that, I got a lot of subs on a couple of clusters, and got a full night session in. Battery maintained its charge throughout the night. The charger kept the charge on the battery. The inverter worked flawlessly, provided the power I needed to run all the gear, and then obviously the gear worked as it should have. So I'm going to call that a successful test. I'm going to probably tighten down a couple things, like maybe permanently attach the charger posts to the battery. But other than that, I'm thinking this is what I'm going to run from now on, using the battery and the inverter rather than direct 120. And with that, I'm going to say thanks for watching. Please hit that like button if you thought this was valuable information. Subscribe to the channel if you so choose. Ring that bell if you want to get notified when I post some new content. And as always, clear skies.
In the upper right, you'll find my latest video. In the lower right, you'll see what YouTube thinks you'll like. And below, you'll see the subscription link. Please check them out.